things are going to change.
If we're not doing this research down here, there's few countries who are going to be doing it.
We've got to make sure that we've got the scientific ability to see whether any changes are happening and respond to it fast enough.
You can't really just look at one part of the Ross Sea without looking at the other parts.
It's absolutely vital that we continue to use the best possible science to track what's going on. Well, the Ross Sea is a great example of an interconnected system. A lot of the ecology is built around the annual cycle of sea ice. And this cycle of ice extending and melting leads to these intense peaks of primary productivity. So all the ecology and all the other animals in the system have to be adapted to cope with this pulse production that happens once a year. So the Antarctic Treaty was set up in order to say that all countries will work in cooperation to manage Antarctica for scientific research and for peaceful purposes. However, at the time, a lot of fishing went on around Antarctica that was unregulated. So in 1982, an extra part of the treaty was agreed, and that was to conserve the marine living resources, and that was called CCAMLR. In 1997, one New Zealand vessel went down to the Ross Sea and caught toothfish. It was so valuable it was termed white gold. It's beloved by very expensive restaurants and it commands quite a high price. Boats pile in and the catches go up very, very quickly. It was a race to get a catch limit put on, and New Zealand managed to get that catch limit agreed through CCAMLR to stop that resource being overexploited. We really pushed for areas where fishing wasn't allowed. To get agreement for a marine protected area took a long time and a lot of debate, probably more than 20 years. But the Ross Sea Marine Protected Area was the biggest in the world. It doesn't actually change the amount of fishing. It moves fishing off the shelf where they were catching smaller fish. Often protected areas are set up in perpetuity, but the Ross Sea Marine Protected Area has a 35-year lifespan. After that point, all the countries have to agree that it's a good idea to continue it. So it's really important that we start gathering that time series information so that in 30 years' time, when they need to look at what role the MPA has had and how climate change has affected it, they know what it was like early on at the start.
It takes over a week to get down to the beginning of the Ross Sea. We're really fortunate that we've got Tonganoa that can come down here. We've got a lot of equipment on board and a lot of experts in different areas. There really are two critical outcomes, and one of them is around the Ross Sea Marine Protected Area, understanding the food web and ecosystem within that.
You get the phytoplankton growing in the surface waters, grows faster than anywhere else in the Southern Ocean. Then you get small zooplankton, which eat that, and you get bigger zooplankton that eat those. And then you get small fish that eat that, and you get bigger fish that eat the small fish, and then the toothfish can eat those medium-sized fish. You also get a large number of top predators in the system, a lot of penguins, plus huge numbers of seals and whales in the area as well. So the whole thing is really highly connected.
We are collecting critical data sets that are going to become the baseline for management.
But then we can also use that data to see if there are changes happening. Our plan for today is to head further out to sea. We've got 3 more moorings to recover and redeploy that are recording sound, essentially.
Great, good to go.
And so if whales are coming past and using their vocalisation, we'll be able to record that. So they should have a total of 8 years of data collection once these next ones are recovered.
One of the most obvious effects might be that if you reduce the abundance of toothfish, the things that eat toothfish can't find enough to eat. In some parts of the Southern Ocean, Sperm whales and killer whales have learned to take toothfish off fishing lines. It's like a dinner bell for the whales, and they move in and they can strip all the toothfish off the fishing line as it gets to the surface. That's never happened in the Ross Sea area yet, and so we're trying to avoid that happening. We're hoping that this builds into a long-term monitoring record for the sperm whales down there. We've got to know that the fishing isn't affecting those connected species in the system, so the science has to provide that information. New Zealand and other countries do a lot of research trying to look at these ecosystem effects of fishing, because if you do have an adverse effect, then it's very difficult to reverse it. So we're trying to assess the role of the MPA when everything else is changing at the same time.
Before you can start forecasting and really understanding the system, you've really got to know what's there and how organisms are distributed and the basic biodiversity. And that information is really poor for many parts of the Ross Sea, just because it's a very difficult place to sample and get to. It always is quite stunning, because you go to a place where there's no life on land, obviously, it's a frozen continent and it's very bare above water. So when you actually put cameras down, man, it's amazing the sorts of things you see. A lot of them are probably new to science. And there's huge, deep coral reef systems that just went on for hundreds and hundreds of metres, beautiful pink coral. We've seen fields of basket stars, kelp beds. Every location we went to, it was often dominated by different species. It had a different look about it. It's obviously untouched, very little or no impact at all from human activity. You can't really just look at one part of the Ross Sea without looking at the other parts. They're all interconnected. There's a very important relationship between the sea ice and the animals that live on the sea floor. One of our key research questions is trying to understand how marine communities in the coastal regions of the Ross Sea will respond to reductions in sea ice going forward.
There is more primary productivity associated with platelet ice than with any other type of ice in the ocean. So it obviously plays a key role and potentially underpins part of the food chain. We want to understand the relationship between the physical environment and the biology that is associated with it. So we need the information in order to better predict how things might change and how they might respond. And then we will have a better idea of what this means for the future.
Toothfish have got a life cycle where the young fish are on the shelf, which is underneath the sea ice. So the question is, how will changes to sea ice because of climate change affect how many of those little fish can get back into the Ross Sea and how much productivity will come into the stock? We need to understand how climate and fishing together in the area are going to affect the system. Ross Sea region is a massive area, already hugely complex, and we can only get down there during the summer, so we can't really know what's happening apart from in 2 or 3 months because of the sea ice.
It's not enough to understand how the ocean works. If you look at the surface, you need to look through the water column, and you need to understand what influences the salinity and the temperature structure and the flows. We don't have free access there all year round, and the benefits of having floats there is that they go wherever the flow decides for them to go. The float will sink to a depth of about 1,000 meters, and it will drift with the current at that depth for about 10 days. Then it will sink another 1,000 meters, and then will go all the way up to the surface. And in the ascent, it will measure temperature and salinity. When there is an ice-free surface, the float is going to come up and transmit all that information to the satellite. The ocean around Antarctica is fundamental for climate. Some of the deep water masses that are part of the deep global circulation are only formed in Antarctica. You really need sea ice to form in order to create these dense water masses. If we want to study how future climate is going to change, we need to start studying the place where all these water masses form. And there are only 3 or 4 places in Antarctica where you found those water masses forming, and one of those places is the Ross Sea.
The opportunity for using technology to go and augment the research vessels into the Ross Sea and the bases in the Ross Sea is huge, I think. It would be really exciting if New Zealand was leading that, revolutionise our understanding of how the system fits together. It's absolutely vital that we continue to use the best possible science to track what's going on and improving on how we're doing it. If we're going to keep across these risks that are going to happen from climate change and from fishing in the region, it isn't going to go back to as it was.
New Zealand Antarctic science was really formative in the establishment of the Ross Sea region marine protected area, and it's critically important in showing the effectiveness of the marine protected area as well. The Antarctic environment is changing really quickly as a result of climate change and human activity. We need to understand those changes to help inform our decision making, and particularly for future enduring protection.
The data we're collecting right now is going to be absolutely crucial for piecing together what's happened, what effect the MPA has had, how things have changed over time, and how climate change has affected things.
Everything that happens around Antarctica, eventually, in the short term or the long term, will have an impact where we live.
New Zealand having the RV Tangaroa, being able to come down here and work in the Antarctic conditions is just such an important thing, and it's an incredible national asset.
Antarctica is largely underappreciated because it's so remote from us, but it really does exert major influence on both the ocean and the atmosphere, which of course makes up our climate. And the Southern Ocean surrounding Antarctica is the most biologically productive ocean on the Earth.
It's a huge store of biodiversity that we need to be able to inventory and understand what's driving that biodiversity, what's driving those ecosystems, and how they might change in the future if we're not careful.